Hello students, so we'll do some of the questions in miscellaneous exercise. Okay, so I will start with question 3. 2 sine inverse 3 upon 5 is equal to tan inverse 24 upon 7. So we have to prove this. So start with LHS. Okay, so same way, that is, you have to put this sine inverse 3 upon 5 as some x. Okay, so using the triangle method, you have to find out tan inverse. Okay, so this will be sine of x equal to 3 upon 5. So using the triangle method, 3, 5, this will be 4. So our tan of x is 4 upon opposite upon adjacent. Okay, so x is tan inverse of 3 by 4. Okay, so we got this. Then this will be 2 into tan inverse of 3 upon 4. Now go for now you have to use the formula, right? 2 into tan inverse 3 by 4 formula, that is the property 2 tan inverse of x, that is tan inverse 2 into x, so 2 into 3 by 4 upon 1 minus x square, so 1 minus 3 by 4 square. Okay, so you'll get 3 by 2 upon 16 minus 9, right? So upon 7 on 16. Okay, so taking this as tan inverse 3 by 2 into 16 by 7, so we'll get it's 24 by 7. This is 24, yeah, right, sorry, 24 by 7. So we got the RHS. Okay, let's solve question 7. Okay, tan inverse 63 upon 16 is equal to sine inverse 5 upon 13 plus cos inverse 3 upon 5. Okay, so I'll first change this sine inverse and cos inverse into tan inverse. So using the triangle method, you can directly also write, okay, sine inverse 5 upon 13 as x, so your sin x is 5 upon 13. So using the triangle method, 5, 13, so this will be 12. Okay, using Pythagoras you will get this as 12. So our tan of x, I'll write directly tan inverse of x as 5 upon 12. Okay, again using cos inverse, so this is 3, 5, I'm taking it as y. Okay, so tan inverse of y will be 3, 5, 4, Pythagorean triplet. Okay, so this will be 3 is adjacent, so 4 upon 3. Okay, so substituting in RHS, you will get tan inverse of 5 upon 12. Okay, this is 10y plus tan inverse 4 upon 3. So using the formula property 5 upon 12 plus 4 upon 3 upon 1 minus 5 upon 12 into 4 upon 3. Okay, so calculating this, you will get 5 3s are 15, 15 plus 48. 63 upon 12 into 3 upon 12 into 3 is 36. 36 minus 20, right? 16 upon 12 into 3. So this gets cancelled and you will get 63 upon 16, which is our answer. Okay. Question 9. Tan inverse root x equal to half cos inverse 1 minus x upon 1 plus x. Okay. So here this is given 1 minus x, 1 plus x. So looking at this, you will understand that this is x is our tan theta. Okay, which will give you cos 2 theta. So substituting x as tan theta. So RHS will be half cos inverse 1 minus tan square. You have to take tan square theta. Okay, 1 plus tan square theta. So you'll get cos 2 theta. So you can write 2 theta. So it will be theta, and theta is our tan inverse of this. You can write x equal to tan square theta. So taking root both the sides, so root x equal to tan theta. So theta will be tan inverse of root x. So this is our tan inverse of root x. This is the answer, required result. Okay. Question 10. Cot inverse root of 1 plus sin x plus root of 1 minus sin x. 1 plus sin x minus root of 1 minus sin x. Okay, equal to x by 2. So you can rationalize this term. Okay, rationalizing means you have to multiply the same term with a positive sign. So rationalizing, you will get numerator will be root of 1 plus sin x plus root of 1 minus sin x. We are multiplying with the same term, so it will be square, and here it will be this square minus this square. So this will be 1 plus sin x minus 1 plus sin x. Okay, here you have to use a plus b the whole square formula. So a square 1 plus sin x plus then b square 1 minus sin x plus 2 times root of 1 plus sin x into root of 1 minus sin x. Okay, upon this 1 and 1 gets cancelled, 2 sin x. This also gets cancelled, so you'll get here 2. You can take common. This will be 1 plus sin x, 1 minus sin x. You can multiply this. So this is a plus b, a minus b. So a square minus b square. So 1 minus sin square x. Okay, 1 minus sin square x is cos square x. Cos square x. Cos square and root gets cancelled. So you can take here 2 common. So you will get final as 2 times 1 plus cos x upon 2 sin x. 2 gets cancelled. 1 plus sin x is, you can substitute as using half angle formula, 2 cos square x by 2 upon sin x. You can write 2 sin x by 2 into cos x by 2. So this one goes. So you'll get cot x by 2. Okay, that you have to write here. So cot inverse cot x by 2 is x by 2. Okay, let's prove this. So looking at this, you should understand that this x will be your cos 2 theta. Okay, so whenever this type of equations are given, you have to use certain trigonometric identities which you should remember. Okay, so substituting x equal to cos 2 theta. Okay, so tan inverse root of 1 plus cos 2 theta minus root of 1 minus cos 2 theta upon root of 1 plus cos 2 theta plus 1 minus cos 2 theta. Okay, so using the formulas, trigonometric identities, this is your 2 cos square theta. Okay, so removing the root, you will get root 2 cos theta minus, this is 2 sin square theta, so root 2 sin theta upon root 2 cos theta plus root 2 sin theta. Okay, so root 2 gets cancelled everywhere, so you will get cos theta minus sin theta upon cos theta plus sin theta. So you can convert this to tan theta by dividing by cos theta in the numerator and denominator, because we want to make it as a tan theta, right? So if you divide it by cos theta in the numerator and denominator, you will get tan inverse 1 minus tan theta upon 1 plus tan theta, and this we know that this is your tan of pi by 4 minus theta. Okay, so this is tan of pi by 4 minus theta, which is nothing but pi by 4 minus theta, and theta, from this you have to write theta, so cos 2 theta so cos inverse of x is your 2 theta, so theta is half cos inverse of x, so you can substitute here and you will get this answer. Okay, next question, 2 tan inverse of cos x equal to tan inverse 2 cosec of x. Okay, so here you can consider this cos x as x, so 2 tan inverse of x, using the property you will get tan inverse 2 into cos x upon 1 minus cos square x. Okay, so this is tan inverse 2 cos x upon sin square x. Okay, now here also tan inverse is there, that is this tan inverse 2 cos x is equal to 1 minus this is sin square x equal to tan inverse 2 cosec of x. So we can equate the angles, so we will get this as this. Okay, 2 gets cancelled, cosec of x is nothing but 1 upon sin x, so 1 sin x and this gets cancelled, so you will get cos of x upon sin of x equal to 1. So you can write this as cot of x equal to 1, so the angle is pi by 4, x is pi by 4. Okay, next question is this, so you have to solve this. So here you can use tan inverse x plus y formula, tan inverse of x minus tan inverse of y. So you have to identify which is your x and which is your y. So this is 1 minus x, so 1 becomes your x and x becomes your y. So you can directly write tan inverse of 1 minus tan inverse of x, okay, which is equal to half tan inverse of x. Now we know that tan inverse of 1 is pi by 4, and I'll take tan inverse of x that side, so it will be half tan inverse of x plus tan inverse of x. So here 1 is there, cross multiplying you will get 3 by 4, 3 by 2 tan inverse of x pi by 4. So this 3 by 2 gets multiplied here, so pi by 4 into 2 by 3 equal to tan inverse of x. So 2 pi by 6 equal to tan inverse of x. So tan of pi by 6 is equal to x. So x is 1 upon root 3. Okay. Next question, you have to solve this. Okay. So I'll substitute tan inverse of x as equal to some y. So you have to find sine from this. Okay. So tan inverse of x equal to y. So your x will be tan of y. Okay. So using the triangle method also you can use. So this will be your sine y equal to tan y tan of y is x. So this is opposite x upon 1, right? So x upon 1. So you have to find the hypotenuse. So hypotenuse will be what? X square plus 1 square equal to hypotenuse square. So your x square plus 1 equal to hypotenuse square. So this is root of x square plus 1 equal to hypotenuse. So hypotenuse is root of 1 plus x square. Okay. So from this you have to write sine. So sine of y is opposite upon hypotenuse. Okay. So y is sine inverse x upon root of 1 plus x square. Okay. That you have to substitute here, sine of sine inverse then. So sine of sine inverse x upon root of 1 plus x square. So your final answer is x upon root of 1 plus x square. Okay, so whenever this type of terms are given, you can use the triangle method. Okay, so that you can convert this to sine inverse, so that you can use sine of sine inverse of x formula. That is the property. Next question, you have to find the value of x. Okay, so I'll transfer this sine inverse 1 minus x that side, so it will be minus 2 sine inverse of x equal to pi by 2 minus sine inverse of 1 minus x. Now using the property which is sine inverse of x plus cos inverse of x equal to pi by 2, from that you can write this as cos inverse of 1 minus x. Okay. Now substitute this sine inverse of x as some theta. So theta will, x will be sine of theta. So from this you have to find cos of theta. Again use the triangle method. So this is your theta, x upon 1 is given. So your adjacent side will be 1 minus x square, correct? Root of 1 minus x square. So from this you can write cos theta, which is root of 1 minus x square. Okay, so cos so sine inverse of x is theta. Same way cos inverse of this will be equal to root of 1 minus x square, right? Because theta is equal to cos inverse root of 1 minus x square. So theta is equal to sine inverse of x, and also theta is equal to cos inverse root of 1 minus x square. So this you can substitute here. So this will be minus 2 cos inverse root of 1 minus x square, and we got this is equal to cos inverse 1 minus x. Okay, now we can put x equal to sine theta or sine y, so that you will get this as cos, this in terms of cos. So minus 2 cos inverse root of 1 minus sine square y. Also you can put this 1 minus sine y. Okay, so this will be cos square y under root, so it will be cos of y. Okay, and here you can use 1 minus sine y. Okay, so this is cos inverse cos y and cos inverse 1 minus sine y. So here you can use the property cos inverse of cos of x, so you'll get y. So minus 2y is equal to cos inverse 1 minus sine y. Okay, so this cos inverse we can take here, so this will be cos of minus 2y equal to 1 minus sine y. Now cos of minus theta is your cos theta, because whenever minus is there becomes plus now. So cos of 2y equal to 1 minus sine y. Okay, now you have to change this to sine. So cos 2y we can write it as using the trigonometric identity 1 minus 2 sine square y. So 1 minus 2 sine square y. Okay, so rearranging the terms. So this will be 2, 1 and 1 gets cancelled, right? So minus minus also gets cancelled. So you will get 2 sine square y minus sine y equal to 0. So sine y you can take common. So 2 sine y minus 1 equal to 0. So either sine y is equal to 0 or 2 sine y minus 1 equal to 0. So sine y is half. Okay, and we had taken x equal to sine y, correct? This was our substitution. So whatever value you get, that is 0 or half, this is the value. Okay, so we can substitute and see. So when it is 0 and when it is half, when it is half you will get the left hand side as minus pi by 6, which is not equal to pi by 2. Okay, so that's why you have to consider x equal to 0. So x equal to half, if you put here, So it will be sine inverse 1 minus half, so half minus 2 sine inverse half. This is minus sine inverse half, which is minus pi by 6, which is not equal to pi by 2. So x equal to 0 is the answer. Okay.